So let's touch on some of that new technology. There's really two new technologies that we have implemented in the new Banks Mill feeds. And the first, you may have heard of it before. Um, it is a marine-derived calcium. It actually comes from red algae. The brand that we're using is a product called CalSea Powder Advance, and it's got such amazing buffering capacity that it will help to reduce gastric ulcers and also enhance bone density because it's really bioavailable for the horses. So I mentioned it's from fossilized red algae, and it's rich in minerals, but primarily a really bioavailable calcium source. On the feed tag, you will recognize it on our feed tags as Calcite. The American Association of Feed Control Officers recognizes that term. That's the correct term. You may see other terms listed on feed tags, marine-derived calcium, but they're incorrect terms. AFCO recognizes it as Calcite. And the main difference between calcite and other products like limestone, which is calcium carbonate, which is a typical calcium source that we will use in equine feeds, is if you look at it under a microscope, it's the structure. And it's a little hard to see in this picture, but if we go one step further, you can see this honeycomb structure. So when you look at calcium carbonate under a microscope, it's got a very solid surface area. But if you look at calcite under a microscope, it looks like this. And you can see because of the honeycomb structure, it's got so many different surfaces that will come in contact with the acid in the horse's stomach to have buffering capacity. But also if we move further down the digestive tract and think about the small intestine where calcium is going to be absorbed for bone health, then it's got a lot more surface areas for enzymatic digestion and absorption. I'm very visual, so I love this graphic of looking at the buffering capacity of three typical buffers that are used in equine feeds and supplements. Sodium bicarbonate, if we take the same quantity, the same weight of each of these ingredients and you look at that soccer field there, sodium bicarbonate has the buffering capacity of like the goal area at the end. Calcium carbonate has the buffering capacity of the circle in the middle. And calcium powder, though, with its honeycomb structure, has the buffering capacity of the whole soccer field, and that's just because of the exponential surface area with that actual physical structure. So why is this important? If I look at the stomach, I can actually break it down into two main sections. If we cut a window in it and we look inside, there's the bottom section called the glandular mucosa, or I'll just call it the protected region, because you can see in the photograph, there's this mucousy coating that covers or lines that dark pink tissue, because that dark pink tissue is constantly secreting, there are little cells there called parietal cells, and they're constantly secreting acid. Because remember, the horse is a grazing animal and he's meant to be grazing for about 17 hours out of the day. And so he doesn't have a meal response. He is continually secreting acid in his stomach. And unfortunately, what happens when we put him in a stall and he's not constantly chewing is that acid will build up and splash up onto what we call the squamous mucosa, or the non-protected region. And right above this line, the line between the two, we call the margo plicatus. And most of our stomach ulcers are going to occur right above that line into that non-protected region. And it's because that acid is building up, it's getting really strong, it's splashing up there. When you think about a horse chewing and swallowing, there's an actual physical mat of fiber that sits on top of that acid as well. But again, if we're not constantly feeding our horses something, then that mat is not there and that acid can splash up. This is a really good graph of a study done at Virginia Tech looking at the acidity in the horse's stomach when they have free choice access to grass hay. So for a 24-hour period, these horses had a little probe down in their stomach. It's a little thing that they swallow. and it measures the acidity. And we measure acidity in the horse's stomach using the unit's pH, which you can see on the left-hand side there. Now, anything between a 4 and a 7, so 7 is the strength of water, that's neutral, and 4, it's starting to get more acidic, but between a 4 and a 7 is the healthy range. You can see that as these horses are eating, the acid is sitting between a 4 and a 7. Anything above this yellow line between that 4 and 7 is healthy. That is normal. But unfortunately, what happens if we take away all of the hay and grain for that same 24-hour period, it takes only 30 minutes for food to pass through the stomach. Now it's going to hang out in the hindgut, the colon and the large colon and small colon and cecum for up to 65 hours, but it can be passed through the stomach in as little as 30 minutes. And you can see here in just 1 hour, the acid in this horse's stomach plummeted down to between a 1 and a 2. And that is the strength of non-diluted, non um, altered or buffered equine stomach acid. But that's not what's supposed to sit in the horse's stomach. It's supposed to sit in there with saliva buffering it and food diluting it. So we've got here by 1 hour, we're down between a 1 and a 2 in that super strong acid. By 18 hours, these horses had bleeding lesions. But what's probably more occurring in our horses is by less than 6 hours, these horses had developed reddening in the stomach lining. And what is reddening? It's inflammation, and that is the beginning of all bad things, is inflammation. And after inflammation, then we start to see ulceration as that tissue wears away and debrides. What's not uncommon this time of year, because it's dark at 5 o'clock, and if it's overcast, it seems to be dark at 3:30. But let's just say we're feeding our horses at 5 o'clock at night. They're done their hay by 7, which means from the last mouthful they took, 30 minutes later, everything can be out of the stomach. And maybe we don't have the luxury of a night check at our barn, or we're not giving our horses night hay and they're eating it really quickly. And we're not coming back till 7 o'clock the next morning. That's an 11 or 12-hour window where the horse has nothing to chew on, and they're literally chewing wood, chewing anything in sight just to try and buffer that stomach acid. So you can see with our pretty benign management practices how easily it can be to create gastric ulcers in horses. About 90% of performance horses have gastric ulcers. About 60% have them in the hindgut, and about half the population have them in both regions. Now, this study was done back in 2005, and we're now in 2020, and I can tell you that these numbers have not changed. They've not gotten any better because we haven't altered the way we manage horses. We haven't altered their stress. We're using a lot of band-aids, but I want to look at practices that we know that there's stress that we can't take away from horses. So we meal feed horses because it's what practically fits into our lifestyle. We have to feed high grain diets to a lot of our horses because they need a lot of calories for energy or weight maintenance. Sometimes we're not feeding enough forage to our diets. We can change all of those things. We can make sure that they've got hay more frequently. We can split up the meals into small meals frequently. We can use more high fat, high fiber type feeds. But what we can't change in a lot of horses is the stress that comes from transport and stabling and intense exercise. Those are stresses that we can't change. The other thing that will cause gastric ulcers is long-term use of non-steroidal anti-inflammatory drugs like bute. And the mechanism is that bute over time will actually wear away at that mucus coating in the bottom part of the stomach, allowing that acid access to that tissue. So what we want to do is add things to the feeds that we're creating that are going to help mitigate some of this stress that we're putting on our horses, some of this decrease in pH that we're seeing. So this was some research done in collaboration with Performance Horse Nutrition and the University of Kentucky, looking at the CalSea powder, replicating the stomach acid environment, And actually at time zero, well, before time zero, we were measuring the stomach acid in a beaker. We've got some hydrochloric acid that's mimicking gastric acid. And then at time zero, we add 3 grams of CalCea powder. And you can see almost immediately we've got a rise in the pH of that acid. And for the length of the study, it continued to rise. And what I think is really good about this is it sat between that 4 and 7 in that healthy range. There are other supplements on the market that we tested that will actually take that acid all the way out of that healthy range and make it kind of the opposite of acidic, which is what we call basic, which is soap or bleach or ammonia. And at that point, we've kind of got some negative effects as well. So we really want the buffering capacity to sit between that 4 and 7, which this did quite nicely. This was some original work done on these algae or marine-derived calcium sources on ulceration in adult horses done in New Zealand. They took 10 horses, varying ages and sex, and did a gastroscopy on day 0 and found every single horse had some degree of ulcers from a 1 to a 3. And then for 30 days, they fed them a supplement containing the CalCea powder. And then on day 30, they did another gastroscopy. And what's pretty significant, I think, is that 100% of those horses significantly reduced their ulcer score, and 70% of those horses had an ulcer score of 0 after 30 days. So the 3 that hadn't gone to a 0 had at least gone down to a 1. So they were pretty minor ulcers. But another area that I think marine-derived calcium is really important for is bone development. And it's so bioavailable that it plays, we know that calcium plays an important role in bone turnover. So if we can feed these young stock and brood mares a more bioavailable source of calcium, is that going to help with bone density? And so this study done in the US had 14 yearlings, 4 geldings, and 10 fillies, and supplemented them with either calcium carbonate or the marine-derived calcium. So they were all getting the same quantity of calcium, but just from different sources. And what we're going to look at here is a bone marker, so a hormone called osteocalcin. And we can measure osteocalcin in the blood, and it is a biochemical marker for bone formation or bone turnover from that cartilage to bone. We're going to secrete more osteocalcin, and so if we've got a lot of osteocalcin, that means that we've got a lot of bone being formed. And so the animals that got calcium carbonate or limestone are represented in the blue bars, and the orange bars represent the horses that were getting supplemented with the marine-derived calcium. And at every time point of the study, 28 days, 56 days, 84, and 112, these horses all had, these foals all had elevated osteocalcin, significantly elevated osteocalcin, so much higher bone turnover and bone formation. Now let's look at a slightly older age group. Now these are still young horses. They were 2-year-olds that were in exercise. They were thoroughbreds in training. And looking at actual bone density in thoroughbred horses. And you can see at 30 and 90 days, the blue bars or black bars represent the horses that were getting calcium carbonate, and the red bars were supplemented with marine-derived calcium. This study is really quite impressive. The increased bone density on 2 different planes of the bone when animals were fed this CalCea supplement.
Animal nutritionists formulate diets to provide carbohydrates as an energy source for livestock. Using different digestive processes, cows and pigs convert these carbohydrates into glucose, which is ultimately released into the bloodstream. Once in the bloodstream, glucose can reach different organs in the body. When the blood reaches the animal's pancreas, beta cells inside the pancreas detect the rising glucose levels. To reduce the glucose level, beta cells release insulin into the bloodstream. As blood circulates through the animal, insulin and glucose exit the bloodstream into tissues to reach the animal's cells. Many of the animal's cells have specific receptors on their surfaces that bind to the circulating insulin. Insulin acts like a key in a lock to open the cell by activating glucose transporters so that the circulating glucose can get inside the cell. The dietary trace element, chromium, is necessary to optimize the activation of the insulin receptor so that more glucose can get into the cell. A maximum of 4 chromium molecules may bind to one insulin receptor, which can lead to an 8-fold difference in insulin receptor activation. Adding supplemental ChemTrace chromium propionate to the diet provides the additional chromium for insulin receptor activation. Chromium enhances this reaction, causing glucose transporter activation, allowing additional glucose to enter the cell. The additional glucose will allow for more energy to be available for proper cell function. Proper functioning cells can lead to a healthier, more productive animal.